Hello students, today we will learn about highest common factor from chapter 3. Let's start the topic. First we will see the definition of highest common factor. The greatest number which divides each of the two or more numbers is called highest common factor or HCF. In simple words, the largest common factor of two or more numbers is called highest common factor. It is also called the greatest common measure GCM and greatest common divisor GCD. Now we will see the steps to follow while finding HCF. The first step is write each number as a product of its prime factors, which means we need to find prime factors of each number and then represent the number in terms of its prime factors. Now list the common factors of both the numbers. The last step is to find the product of all common factors. And the product of all common prime factors is the HCF. Now we will solve some questions from exercise 3.6. Let's solve question number 1 of exercise 3.6. Question number 1 is find the HCF of the following numbers. Number A, 1848. As we have discussed about the steps to follow while finding HCF, so first we will find the prime factors of 18 and 48 separately. And then we will represent 18 and 48 in terms of its prime factors. Then we will list the common prime factors. Now we will find the prime factors of 18 and 48 separately. So first we will find the prime factors of 18. So let's do the prime factorization of 18. In the first step, we need to find the smallest prime number which can divide 18 exactly without leaving any remainder. Since we know that 18 is exactly divisible by 2, we can divide 18 by 2. When we divide 18 by 2, we get 9 as the question. And now we need to find the smallest prime number which can divide 9 exactly. Since we know that 9 is exactly divisible by the prime number 3, we divide 9 by 3. And when we divide 9 by 3, we get 3 as the question. Now we need to find a prime number which can divide 3 exactly. So 3 itself can divide 3 exactly. When 3 is divided by 3, we get 1 as the question. So the prime factorization of 18 is done. And the prime factors of 18 are 2, 3, and 3. Now we will do the prime factorization of 48. So we will find the smallest prime number which can divide 48 exactly. And as you can see, 48 is exactly divisible by the smallest prime number 2. So we will divide 48 by 2. And the question will be 24. And now we will find a prime number which can divide 24 exactly. So 24 is again divisible by 2. And when we divide 24 by 2, we get the question as 12. And now, again we need to find a prime number which can divide 12 exactly. So we will divide 12 by 2 again and the question will be 6. And since we know 6 is also divisible by 2, so we will divide 6 by 2 again and the question will be 3. Now since 3 itself is a prime number, so it is divisible by 3 only. So when we divide 3 by 3, we get 1 as the question. So now the prime factorization of 48 is done. And the prime factors of 48 are 2, 2, 2, 2, and 3. Now since the prime factorization of both the numbers are done, we will represent the numbers, that is 18 and 48, in terms of their prime factors. So now we can write 18 as 2 into 3 into 3, and 48 can be written as 2 into 2 into 2 into 2 into 3. Now here we can see only 1 times of 2 and 1 times of 3 are common. So the HCF will be the product of 2 and 3. So HCF will be 2 into 3, which is 6. Therefore the HCF of 18 and 48 is 6. Now let's solve number G of question number 1. Number G is 70, 105 and 175. So here we need to find the HCF of 3 numbers. Here we will first find the prime factors of 70, 105 and 175 separately, and then we will represent these 3 numbers in terms of their prime factors. Then we will list the common factors. So now we will find the prime factors of 70, 105 and 175 separately. So first we will do the prime factorization of 70. So here we need to find the smallest prime number which can divide 70 exactly without leaving any remainder. Since we know 70 is exactly divisible by the smallest prime number, that is 2, we divide 70 by 2. So when we divide 70 by 2, we get 35 as the quotient. Now again we need to find a prime number which divides 35 exactly without leaving any remainder. So 35 is exactly divisible by the prime number 5. And when we divide 35 by 5, we get 7 as the quotient. And we know that 7 is a prime number. So 7 can be divisible by 7 only. And when we divide 7 by 7, we get 1 as the quotient. So the prime factorization of 70 is done, and the prime factors of 70 are 2, 5 and 7. Now let's do the prime factorization of 105. So here we need to find the smallest prime factor which can divide 105 exactly. As you can see, this number is exactly divisible by 3, so we divide 105 by 3. And when we divide 105 by 3, we get 35 as the quotient. And again, we know that 35 is divisible by the prime number 5. So we divide 35 by 5. And we get 7 as the quotient. And since we know that 7 is a prime number, we will divide 7 by 7 itself. And when we divide 7 by 7, we get 1 as the quotient. So the prime factorization of 105 is done. And the prime factors of 105 are 3, 5 and 7. Now let's do the prime factorization of 175. So even here, we need to find the smallest prime number which can divide 175 exactly. So we will start with 5. And when we divide 175 by 5, we get 35 as the quotient. And again, we need to find the smallest prime number which can divide 35 exactly. We know that 35 is divisible by 5. So when we divide 35 by 5, we get 7 as the quotient. And since 7 is a prime number, so it is divisible by 7 only, and we will get 1 as the quotient. So the prime factorization of 175 is also done. And the prime factors of 175 are 5, 5 and 7. Now we will represent these 3 numbers in terms of their prime factors. So we can represent 70 as 2 into 5 into 7, 105 as 3 into 5 into 7, and we can write 175 as 5 into 5 into 7. As you can see, 1 times of 5 and 1 times of 7 are common here, so the common factors of all these 3 numbers are 5 and 7. So to find the HCF, we will multiply 5 and 7. So HCF will be 5 into 7, which is equal to 35. Therefore, the HCF of 70, 105 and 175 is 35. Now let's solve question number 2. Question number 2 is, what is the HCF of two consecutive number A numbers? Consecutive numbers means the numbers which do not have any number between them. So the HCF of two consecutive numbers is 1. Example, the HCF of 2 and 3 is 1 because 2 is a prime number as the factors of 2 are 1 and 2. And 3 is also a prime number as the factors of 3 are 1 and 3 only. Since the largest common factor is 1, so the HCF of 2 and 3 will be 1. Now let's solve number B of question number 2. Number B is even numbers. So the question is, what is the HCF of two consecutive even numbers? Consecutive even numbers means two continuous even numbers. For example, 2 and 4, 6 and 8. So the HCF of two consecutive even numbers is 2. Example, the HCF of 2 and 4 is 2 because the factors of 2 are 1 and 2 and the factors of 4 are 1, 2 and 4. So here the largest common factor is 2. So the HCF will be 2. Now let's solve number C of question number 2. Number C is odd numbers. So the question is, what is the HCF of two consecutive odd numbers? Consecutive odd numbers means two continuous odd numbers. For example, 3 and 5, 7 and 9, 9 and 11. So the HCF of two consecutive odd numbers is 1. Example, the HCF of 3 and 5 is 1 because the factors of 3 are 1 and 3 and the factors of 5 are 1 and 5. Here the highest common factor is 1. So the HCF will be 1. That's all for today. Thank you.